Hello everyone, in this video we'll discuss a numerical on coefficient of insensitiveness. So the question says that the controlling force F and the radius r of rotation, that is in mm, and force is in Newton, right? For a spring-loaded governor, it is related by an expression F is equal to 3r minus 18. Now, what all data are we given? We are given the mass of the ball, which is 5 kilogram. We are given extreme radii R1 and R2, 100 and 180 mm. We have to calculate maximum and minimum equilibrium speeds. Also, the question says that if the friction is given as 18 Newton, we have to find the coefficient of insensitiveness at extreme radii. That means at 180 mm, we have to find the coefficient of insensitiveness. So we are given this equation F is equal to 3r minus 80, right? And we know the value of radius for both the conditions 180 and 100 rpm. We put the value of radius and we get the value of controlling force for both the cases. Now we know in equilibrium position controlling force is equal to centrifugal force, which is mr omega square. So in case 1, mr1 omega 1 square is equal to 460. You place omega as 2 pi n upon 60, put the values and you get the value of n1 as 215 rpm. Similarly, we'll do it for the minimum radius, which is 100 mm, right? Force is mr2 omega 2 square. You know the value. You put the formula for omega, that is 2 pi n upon 60, and we get the value of n2, that is 200.3 rpm. Now we know that the friction at each ball is equivalent to 18 Newton. So the controlling force becomes for maximum radius condition, friction 460 plus 18 and 460 minus 18. Now we already know that friction, it acts in the direction opposite to that of the motion. So when ball or the sleeve it moves downward, friction acts upward, that means minus 18. And when the ball or the sleeve it moves downward, friction acts upward, and when it moves upward, friction acts downward, which is plus 18. So the two F1 and F2 we have got, right? Now we know that force is mr omega square and omega is 2 pi n upon 60. So from this relation we can deduce that n square is directly proportional to force. If you remove this proportionality sign, we can put a constant, which is n square is equal to kf. Now the formula for coefficient of insensitiveness is n1 square minus n2 square upon 2n square, where n is the average of n1 and n2. So instead of calculating the values of n1 and n2 and n, we can directly put the values of f1, f2 and f. So in this, k being a constant factor, it gets cancelled out, right? You can put the value of f1, f2 directly from here, and for f you can do the average 478 plus 438 upon 2. So we get the value 458. You do the calculation and get the answer, which is 4.3%. Now because the question is talking for extreme radii, so we have to calculate coefficient of insensitiveness for both the radii. So maximum we have calculated. For minimum radius, again we know that force without friction was 220 Newton, right? Now friction, it gets added up and subtracted depending upon the motion of the ball and the sleeve, because friction is acting in the direction opposite to that of the motion. So in one case you add up 18 and in one case we subtract 18, and these are the value of two forces that we get. Now because I've already found out a relationship of n square and f, and we have already replaced the value in the formula, we can directly use this formula in second case. So coefficient of insensitiveness becomes f1 minus f2 upon twice of f. You put the values of f1, f2, f is average of these two, and we get coefficient of insensitiveness as 8.1%. Thank you.